Episode 5. How do black holes die? The universe's greatest predator eventually becomes its smallest survivor. For trillions upon trillions of years, a black hole drifts through an aging universe. Growing colder? No. Something even stranger happens. The smaller a black hole becomes, the hotter it gets. It begins releasing energy faster and faster until one day, after surviving longer than almost anything else in existence, its story finally reaches an end. But how does the darkest object in the universe die? Throughout this journey, we've learned that black holes slowly lose energy through Hawking radiation. For almost their entire lives, the change is impossible to notice. A black hole with the mass of our Sun would outlive stars, galaxies, and almost everything else in the universe for billions of years, then trillions, then numbers so enormous they're difficult to imagine. The black hole continues shrinking very, very slowly. But something remarkable is happening. As the black hole loses mass, its temperature rises. That's the opposite of almost everything we experience on Earth. Normally, large objects cool down over time. A black hole does the reverse. The smaller it becomes, the more energy it releases, and the faster it changes. Imagine a candle. For most of its life, the flame barely changes. It burns quietly, steadily. But as the last drops of wax disappear, the flame suddenly burns brighter. A black hole behaves in a surprisingly similar way. For almost its entire lifetime, nothing dramatic happens. Then, as it becomes smaller, it begins releasing energy more quickly. This makes it lose mass faster, which makes it hotter, causing it to release even more energy. A cycle begins, with each step accelerating the next. For unimaginable lengths of time, almost nothing changes. Then, in what would seem like a single moment on the cosmic timeline, everything changes. The ending arrives all at once. Physicists believe that in its final moments, a tiny black hole would release its remaining energy in an incredibly intense burst of radiation. Not because something escaped from inside, but because there is simply nothing left. The object that once bent space, captured stars, swallowed light, and shaped entire galaxies has completely evaporated. The event horizon disappears. The black hole is gone. Exactly what that final instant looks like remains one of the greatest mysteries in modern physics. The universe is only 13.8 billion years old. No black hole has existed long enough for humanity to witness its death. For now, the ending exists only inside the mathematics. But even if black holes disappear, one question refuses to disappear with them. What happens to everything they swallowed? The stars, the planets, the light, every atom, every piece of information. According to quantum physics, information cannot simply vanish. The laws of nature suggest it must always exist somehow. Yet black holes seem to erase it forever. This puzzle became known as the black hole information paradox. It challenged some of the greatest minds in science. Stephen Hawking spent decades trying to solve it. So did physicists around the world. Even today, there is no complete answer. Some believe the information somehow escapes. Others think it remains encoded on the event horizon itself. Some believe the answer may require an entirely new theory of physics. Solving this mystery could finally unite Einstein's theory of gravity with quantum mechanics, a discovery that could completely transform our understanding of the universe. More than a century ago, Albert Einstein changed the way we understood gravity. Soon after, Carl Schwarzschild revealed that Einstein's equations predicted objects so extreme that even light could not escape. Astronomers spent decades searching for evidence. Stephen Hawking showed us that black holes are not eternal. In 2019, humanity captured their shadow. Every discovery answered one question and revealed another. We've learned how black holes are born, how we found them, how they lose mass, how long they survive, and how they may finally die. But perhaps the greatest mystery still lies ahead. If black holes hold the answers to gravity, quantum physics, and the fate of information, could they also hold the key to understanding the universe itself?
How about how? Every question has an answer.
Coming next, the story of time. What really is time?